Ask a large language model a question and notice what it does not do. It doesn't look anything up. Everything it knows is frozen inside its weights, baked in the day training stopped. So ask it about your company's internal docs or yesterday's news, and it does something risky. It guesses, fluently, confidently, and sometimes completely wrong. We call that hallucination. But really, it's just a model doing the only thing it can, predicting plausible words with no source of truth. Now, imagine handing that same model an open book. Before it answers, we give it the exact pages it needs. It reads them, then responds, grounded in real text instead of memory. That is the whole idea behind Retrieval-Augmented Generation, RAG. Retrieve the right knowledge, augment the prompt with it, then generate. 3 steps, and the magic is almost entirely in the first one. How do you find the right pages out of millions in milliseconds? Here is where it gets beautiful. To search by meaning, we first turn text into numbers, not random numbers, but coordinates. Every chunk of text becomes a point in a vast space, hundreds of dimensions wide. That point is called an embedding. And the models that create them are trained so that meaning turns into geometry. Sentences that say similar things land close together. Unrelated ideas drift far apart. Reset my password and I forgot my login, use different words, yet land almost on top of each other. The cat sat on the mat, sits in a completely different region. In this space, distance is meaning. So to find relevant text, you don't match keywords. You drop the question into the same space as a point and look around it. Its nearest neighbors are your most relevant chunks. That's why RAG can find the right passage even when it shares not a single word with your question. But there's a catch. A real knowledge base has millions of these points. Measuring the distance to everyone for every question would be far too slow. So we cheat cleverly. Algorithms like HNSW build a navigable map of the space, a network of shortcuts. So you can hop to the right neighborhood in a handful of steps instead of scanning everything. Approximate but astonishingly close, and thousands of times faster. That is what a vector database does for a living. So let's assemble the whole machine. RAG runs in 2 phases. First, indexing, done once ahead of time. Take your documents, slice them into chunks, run each through the embedding model, and store the points in the vector database. You've built a searchable map of everything you know. Then, at query time, the user asks something. You embed their question, find the nearest chunks, and paste that retrieved text into the prompt, right beside the question. The model now answers with the evidence sitting in front of it, and because it's quoting real sources, it can cite them. You might ask, why not just teach the model this directly, by fine-tuning? Because fine-tuning changes how a model behaves, not what it can look up. It bakes patterns into the weights slowly and expensively. And the moment your data changes, it's stale again. Fine-tuning is how it thinks. RAG is what it knows. And why not paste all your documents into today's giant context windows? You can until you can't. Cost scales with every token, over 20 times more at scale. And moderns get strangely forgetful in the middle of very long inputs, missing facts buried between the start and the end. RAG sidesteps all of it by fetching only the few passages that matter. So this is why RAG became the backbone of serious AI systems. Its knowledge is always fresh. Update the database and you're done. Its answers are grounded in real sources, which cuts hallucination and lets you show your work. It keeps private data private outside anyone's training run. And it does all of this at a fraction of the cost. That's RAG at its core. Turn meaning into geometry, search by nearness, and let the model read before it speaks. But a simple RAG system and a genuinely great one are worlds apart. And the whole difference is in the details. How you slice the text, how many chunks you fetch, how you re-rank them, and a frontier of techniques that make retrieval actually intelligent. That's part 2. If this made RAG click, subscribe, and I'll see you there.